Thank you very much. So last time I spoke, Alex had a nice Raspberry Pi cluster behind him, but that's not what he's going to speak about today. Today he's going to bring our cloud networks to the next level, and while doing that, he will kill all nasty VPNs. And how better to secure the future than with cert-manager. Hello, Alex.
Hi, thanks for having me, everybody. It's good to see so many friendly faces on the chat. Today we're going to look at some advanced cloud patterns that you can actually employ with inlets, and that cert-manager makes really easy as well. And I'm not going to say Istio once, hopefully, because you don't need it. It turns out that actually using existing tools, we can build really interesting networks and solve problems. So the best tweets today will be getting swag, so you know how this works. First of all, I'll tell you a bit about inlets, the proxy and the tunnel that you might have heard of, the traditional use case, but then we'll look at also what are the alternatives and what other things can we use it for. Particularly, I want to take you on a bit of a journey through use cases. I always think it's important to think about, great, well, what's the problem we're solving with this technology? The hybrid cloud will hopefully speak to a few of you. Multi-cloud federation, that's where we can actually federate Prometheus. I only found out about this last week, and it is very cool. And then we'll get a couple of demos with cert-manager in the mix as well, recap everything, and give you a few pointers to go off from there and try it out for yourself. So Inlets started as an open source project. There's just over 6,000 GitHub stars on it now. There's more than one repo. There's not only the open source free version, but there's also a commercial version of it too, Inlets Pro. Now, what is it? Well, it's a service proxy, a bit like NGINX or Caddy, but it also is a network tunnel. And you may have seen network tunnels in the past in things like ngrok. Now, this differs a bit from a VPN, like Marta said. This is working at the HTTP or the TCP level. So we're not pushing IP packets around, we're actually talking to applications. And that's one of the things that makes it really easy and powerful. The way that it transmits its control plane is over WebSocket using TLS. Thank you, cert-manager, for helping with the TLS. Now, that means it can actually penetrate pretty much any kind of network conditions you can come up with. Captive portal, center parks, chalet, you name it. You can pretty much run this from wherever you like, even over a HTTP proxy. But unlike tools built 10, 15 years ago, or VPNs 20, 30 years ago, it's actually been built 18 months ago and enhanced since then for cloud native. So it's really looking to work with VMs, containers, and Kubernetes as a first-class citizen, Mac, Windows, and Linux. It's written in Go, and it's very portable. It's also easy to automate, and I think that's because it's just been designed to do one thing, which is to tunnel traffic, and then we have these automation tools around it to help us put bits in the right place. And as I say, it can be used as a VPN alternative, but there are still lots of valid cases where you want the VPN instead. Now, when you think about networks, we have these private networks and public networks, and there's a very big difference between the two. Private networks, well, you just don't have a public IP most of the time. If you do, it changes, and you don't want to expose yourself on the internet. You need NAT to get behind the computers there. You've probably got a firewall if you're at work, and you maybe can't even open a port, or it's a big job to try and do that. When it comes to corporate proxies, again, it's hard to push traffic through them. Public networks, on the other hand, they're very easy to use. The world is your oyster. You get public IPs for almost for free, but that is going to start coming to an end soon with the capacity dropping and then running out. So we've got pros and cons on both sides. The idea here is that we can perhaps bridge the networks together to get the benefits of both. Now, your traditional use case is you're running a client on your laptop. Maybe you've got a webhook receiver, written it in Node.js, HTTP port 3000. We've all been there. But we want GitHub to send us webhooks, and it just isn't going to work. Therefore, we can run a client which establishes a WebSocket outbound. That's how we get past the restrictions. Once we've got the tunnel, it's fair game. And when GitHub talks to us, it's like it's talking to our laptop directly. The terminology for that public-facing part with the IP is the exit server. Now, this is what it would look like if you use the open source version of Inlets. This is level 7 HTTP based. You have the client. You specify the URL of the server. This is a WebSocket, remember, and it's using TLS. You have an auth token that's symmetrical. They both share that. You say that upstream, just like in NGINX, where am I going to go when I get traffic? Well, I'm going to go to that node service. On the server, you have that symmetrical token again, and then you can bind either to all your adapters, or maybe you just want to bind to localhost and then let something like Caddy take over and provide your TLS. Now, that's probably the best use case for a VM running the open source version. But if inside Kubernetes, you can use Ingress, you can use cert-manager to get your TLS instead. And we'll see that in a minute. Now, Inlets Pro gives you level 4 TCP style tunneling. So here we can actually do things like MongoDB, Redis, maybe or NGINX itself. We can even tunnel that because the pure raw bytes will come back to your client from the internet. It's very similar. We have an upstream host instead of a URL. We have the ports we want to expose, and you can have a large list of them if you need it. There is a license, a JOT, that you can purchase. And then again, you need a URL where you're connecting to, the auth token. And so it all looks very similar, but Inlets Pro also adds its own PKI. So it can create and sign certificates for you so that if you're not needing to build like a complete infrastructure and automation with cert-manager, you can get something secure very quickly. Okay. Now, one of the benefits here is that it's effectively unlimited. You control this, you self-host it. So your control plane, that WebSocket is secured with TLS. Great. No snooping. We can expose whatever ports we want. There's a strict access control list so that people can't just get into your cluster if they hack your server and start pinging other computers in your network. It's very important. And it encrypts the data plane. Now this one is a little bit harder to get your head around. You imagine we're running MS SQL, not MySQL. I'm talking about a Windows computer in your data center. And let's say it doesn't have TLS enabled and there's no auth on it. You're not going to expose that on the internet. It would be a very bad idea. Well, what you can do is push it across the tunnel. It will encrypt the data. And then on the other side, whether it's a pod or a container or a bare metal host, Mac, Windows or Linux, you can then decide if that data plane is public or private. If it's private, then you can connect to it from within the cluster and make use of an existing asset, okay, without having to worry about potentially breaking that old Windows machine by trying to force TLS into it or force auth. And the alternative here is versus a VPN, right? But there's no IPAM woes, no routing, no Linux issues. You don't have to buy, you don't have to sort of go on to Stack Overflow all day long. It just works. Now, because it does a simple job, and you've seen those are the command line options, it's basically all there is, it's very easy to automate it. And we've seen a community ecosystem come up around it. And what these exist to do is to lower the barrier, because it is just too easy to use a SAAS tunnel, right? You type one command, it's live, you've got HTTP traffic. Very easy. So we wanted to try and make it as easy as that, but with self-hosted VMs. Now these cost between $2 and $5 per month to host. If you use an individual cloud VM just to expose one thing, use Inlets control. If you've got a Kubernetes cluster, Marta mentioned my Raspberry Pis, and by all means run K3s on it, install the INLETS-OPERATOR, and then that will get you real IPs by creating those VMs, and you'll get traffic to your computer. You can also run this on your laptop. We'll see a demo of that. Terraform is fair game, so is manual setup, whatever suits you. Now remember, we need to secure that control plane. With the open source Inlets, we tell you how, but we don't do it for you. We don't hold your hand. So if you're an expert, fair game. but INLETS Pro has built-in PKI. It has ability to use TCP as well, but both of them can use cert-manager. And if you have an enterprise CA, you can actually make use of that with Verify through cert-manager, which I think is pretty cool, pretty useful. More of that on GitHub. Now, where does this fit in? Because, you know, we sort of think about this. Well, what is INLETS for? Is it an ngrok replacement? Is it a VPN? Nobody really knows, right? Well, this is where it sits on the cloud native landscape. It is a service proxy, but it doesn't really fit here because it also has superpowers. It's a tunnel as well. And I'll have to check, but I'm pretty sure none of the ones listed here have that. So we want to compare it to something else, perhaps. It would be WireGuard or a VPN. And this is something that people will often say, perhaps when they're not that well informed about the area, they'll say, well, what about X? And it's fair to say it. When you use INLETS, you're really looking at applications or services. There is a topology that looks a bit more like a star, where you have clients coming back to a server. I'm talking to a company at the moment, and they're thinking of doing sort of tens of thousands of connections of IoT devices back to a single control plane. You probably don't want to create a VPN mesh for that. It's going to be very messy. You run out of IP addresses, all sorts of issues there. But sometimes you do want a mesh where every computer in your entire facility, in site to site, they're all linked together and they can talk at level 3, which is much, much lower down. That's the IP level. And that might be what you need. If you're replacing a corporate VPN, if you want to access your Raspberry Pi from home, perhaps that's for you. So that hopefully that gives you a bit of an idea, and I'll give a bit more detail now. So Tailscale, very popular at the moment. It's built on WireGuard. We're really looking at connecting nodes rather than connecting together services. Okay. So when we think about cloud native and things like Istio with all the traction behind them, they don't connect nodes. In fact, they've moved away from node-based service meshes. It's all about the services now. But they have a real advantage that they work at the UDP level and they use that for transport, which means they're really fast and they can run a full stack of TCP on top of that if needs be. Now, the commercial offerings are billed per user. We want to work with services, so it doesn't really map very well, does it? And there's no ability to have public tunnels unless you do a lot of extra work. Now, not to mention, if you've ever tried WireGuard, and I was playing around with it last night, it's very easy to mess up the NAT rules. There's a lot you have to think about, including the IPAM, and it might be worth it. It's definitely better than IPsec in terms of usability. INLETS, HTTP or TCP. Those are your two options. And then we're looking at securing service-to-service connections between clusters or perhaps private public clusters, it doesn't matter. Your tunnels can be public if you want. It's cloud native. You can have a Kubernetes load balancer. All the tooling for around it is open source and you can just run it wherever you need to. Now, when we look at SAASes like ngrok, I'm a big fan of ngrok. I use it quite a lot, but it was often blocked wherever I worked and with clients. The free version limits you to 60 connections per minute. If you pay, that's only up to 260, so you can't really use that for clients. The URL, unless you, again, register, changes after 7 hours. But don't get me wrong, it's a very useful tool for just a quick fire and forget. No private tunnels with this, no Kubernetes integration, but they're doing a great job, and if it's useful to you, carry on using it. And the other one is Cloudflare Argo, and actually really think they're doing a great job here. There's an Edge CDN, so I can get that Raspberry Pi I showed you and have, single-digit latency in Japan. I can't think of any other way of doing that. I wouldn't want to manage all the infrastructure for that. They'll do it for me. They create a tunnel to all their edge locations, as long as I am a customer of theirs, I use their DNS and their ingress controller. I can't use things like ingress NGINX here. I can't expose things like MySQL as far as I'm aware. And, there's no private tunnels. So we can't really use it for the hybrid cloud, multi-cloud use case. Now, INLETS itself, it doesn't have this rate limiting. You probably should put something in place just to prevent abuse, but it's not there by default because it's self-hosted. It means you decide the limits. Now you can also use whatever ingress controller you want. You can use cert-manager, you can even have a load balancer in your Kubernetes cluster, or just deploy plain YAML pods. That also means you can use your own DNS. You don't have to rely on, let's say, like the Cloudflare one, and public and private is a choice that you can make. So back to the use cases, and this is where I think it gets quite interesting. Tobias Brunner from Fission AG over in Switzerland, he says, we offer managed Kubernetes to regulated institutions in Switzerland. Our customers' VPCs do not allow incoming connections. We want to manage them, we want to manage their OpenShift clusters. Now, regulated institutions in Switzerland, that sounds a little bit James Bond to me, and maybe it is. Regulated institution sounds a lot like banking. I don't know what you think to that. So have a look at this diagram. On the left, we've got Bank 1 and Bank 2. They both have a private VPC with OpenShift and its API server. Okay, no way into that. But if you remember the diagram I showed you with GitHub, we found a way around it. We run the INLETS client inside the private VPC, punch back to a SAAS control plane using cert-manager to provide TLS certificates for our WebSocket, so we're all good and encrypted. And then from within the cluster, the customer portal, let's say it's written in Node.js, can just talk to the Kubernetes service, and it will be like it was actually in Bank 1's cluster. You won't know the difference. And so this is something that is already being used in enterprise, in really restricted environments. And I think this is kind of an interesting model for SaaS companies. Imagine that you're kind of a CodeFresh or Circle CI. You've built this great SaaS platform, you run jobs for people, but then actually you need to just poke in from time to time and actually run something on one of their runners or fire off an end-to-end test and get a result back. This might be an option for you. Now, the other one that I sort of alluded to this earlier was, let's say you've got a legacy hypervisor, I don't know, Hyper-V, VMware. You've got a Windows VM there, and it's running MS SQL, so it's not, you know, this is the really old version. It's about as far away from cloud native as you're going to get, but it exposes TCP on 1433. Okay, it may have auth, it may not. It may use TLS, it may not. What we do is we set up a Kubernetes cluster with a load balancer, run NGINX there maybe, or Caddy. Cert-manager gets us a TLS cert for the WebSocket, and then our data flows over that WebSocket to the back end, and our monthly report just happens to be written in Node. You know, something on the other end of the spectrum can talk to that service as if it was really there, query it, get the data it needs. And this is a way that we can present a hybrid cloud to customers and clients in a very easy way. Right? You don't have to think about IPAM. You just have a basic ACL of what you can talk to. You set up an auth token. You run a pod. You're pretty much there. Okay. So let's do a demo. This demo is the first one that you're going to see. And we're going to build a registry because apparently that just happens to be what everyone's doing right now. Now, this is where we talk about the use case where you're on your own computer. I'm going to run a bunch of commands using Arcade. What is effectively happening is I'm going to install the INLETS-OPERATOR I mentioned. I'm going to install cert-manager and ingress NGINX. This gives me my tunnel, my load balancer. This gives me certificates, and that gives me a way of getting data in. After that, I will install the Docker registry. I'm going to output the credentials into a text file. And then this is an interesting bit for me. We had this idea in Arcade that we could perhaps generate an ingress for you rather than you having to do it yourself and mess about with YAML. So this just creates an ingress record for me, and we're going to do it on my domain. It's going to be reg dot. Okay. Now in the meantime, let's have a look and see if we've got a public IP yet. Still pending. Let's see if our deployment of the inlets operator is good. Looks happy. It's gone off and provisioned this a VM on DigitalOcean. It has got the IP back now, so we should be able to see what that is. And I want to ask you, have you ever seen a load balancer come up that quickly on any cloud? I think the answer is probably no. So, right, our ingress should be in place now. Let's have a look for that. Yeah, we got that. But it's not going to work yet until we set up a DNS record. This is using HTTP 01. Let me see. Teach me. Okay, so I've created I'm going to create a DNS record for that now. And hopefully the time to live will be short. The cert-manager will see it and it will give us what we're after. Let's see. We want to see the certs. Not quite ready yet, but we should see that if we ping our domain, that our IP is there. Is that the right one? It's the wrong one. Let's give it another go. Domain create IP address. Another go. And this time I'm going to type it in manually just because I want to trust it. Okay. Let's see how our certificate does. It might take a few moments, but once that's up and running, in fact, we've already got a load balancer for NGINX. We're already going to be receiving traffic on that IP. It's just now down for that DNS record to be propagated, the cert-manager to do its thing with the challenge, to issue the cert, NGINX to reload it, and at that point we can run Docker login with the domain, we can tag an image and push it, including the authentication, and we can then say goodbye to GitHub or goodbye to the Docker Hub, and we've got our own hosted solution. Now that would also work with things like Harbor, right? There's no need to necessarily use the open source solution. These commands are also on a blog post. You can find that later on. Well, this is one that I eventually got working. It was Johan Siebens, a guy from the community that put this together. And the idea was federated Prometheus. This is your multi-cloud. So here we've got AWS at the top. Maybe we're using burstable instances that are a bit cheaper, or spot instances. Below, we've got Packet with bare metal, high performance, high cost. And we want to sort of blend the two. Maybe we're running OpenFaas, maybe we're running a customer's site. But how do we do that? Well, it turns out Prometheus has a federation feature, and it's just a case of scraping Prometheus. So Prometheus on the right-hand side happens to be on GCP, scrapes Prometheus on the other side, brings all the network metrics together, aggregates them in one place. From there, you can use Grafana to view the data, set up alerts, and it's all relatively simple. Now, I can actually show you that because that's one that I did prepare earlier. If I switch into context for it, and then I port forward back the Prometheus that I'm running on the middle cluster, we can go ahead and here we are. Now, under the status, we've got our targets. One of them happens to be down at the moment, the other one's up as we're reloading. And we see inlets Prometheus packet, so that's been scraping data from there. These are all the pods it brings back, so you can actually say what you want to bring back. You don't have to just be lumbered with the whole lot. And then I believe under service discovery again, we'll see the 2 clusters that have been discovered and what their IPs are. And these IPs are that virtual inlet service that's running inside the cluster. From there, we can click on the graph, and I've actually deployed OpenFaas in both of those clusters. And what you'll see is that we have this cluster name here, app Kubernetes IO name, Prometheus packet. Again, if we make the window big enough, say let's say over the last day, we should be able to put that in our query, and then we can also put in a query about AWS, and we can see the data that's come back from that. So now we can aggregate all the data in one place, we can manage and monitor multiple clusters. Maybe that helps you out in your SAAS, maybe it helps you out scaling across different regions. There's all sorts of things you can do there. Now, to enable this sort of use case, well, do you really want to be managing the customizing the YAML and deploying the clients, deploying the servers, setting the tokens? I think if you've got a few, maybe you do. But when you start to get to the point where actually you've got hundreds, if not thousands of these clients, and they all need their pod on the other side, and they all need to go through cert-manager, they're either exposed publicly or we access them from within the cluster, you need something else. And that's where INLETS-CLOUD comes into it. Now, this is something that I've put together over the last few months, and basically from customer feedback that they want to manage hundreds of thousands of inlets tunnels. Okay. There's a CRD for this called exit tunnel, and there's also a CLI. The data plane and the control plane are separate. So you can have the control plane, we need to have it on all the time, and you'll be -tunnel in your domain. The data plane you can disable if needs be. Okay. Now, this is what it looks like. We've got list, create, connect gives you a connection string for the client, rotate will delete the password and give you a new one. And actually have 2 devices set up here. You can see them on the screenshot. They're right behind me down there. And they're connected right now. So if I run the CLI and list, let's get into the right cluster, all of my clusters. This shows me what I've got there now. We've got the Prometheus and packet from earlier, from our federation. We've got sensor 1. Okay, let's try out sensor 1. And it's giving me some data back. One of the readings is the red value. The sensor's not actually on right now, so we're getting that feedback. The other one I've got there is the LED 2. But actually, I think in my data it says LED. And so if I open this, it's not connected to anything yet. To create a tunnel, it's simply a case of running create LED1, created, and then running connect LED1 in the domain. And there we are. Now, Alistair, I guess you're going to hear this a little bit later after I say it, but do you want to create one of your own tunnels and connect it? Now you can see over on my, if I can get into my LED1, yes I can. Python app that turns out it's already running. I'm now going to run my tunnel given the string I was provided with, and we can now see it. We can turn it on, and we refresh the sensor, look at the red value, because it's a red light. In theory, well, it's not actually come on, but in theory it would have actually just put that on for us. So there's a full end-to-end demo. Future plans include potentially being able to use a REST API with this, being able to manage it in one place, get metrics, scale it down to 0, because running thousands of pods, as we know, is probably going to be exhaust some limits in Kubernetes at some point. Now let me see if I can get onto Alistair's tunnel that he's just created, just there. And he's got a version of the INLETS website. He's been helping us add a blog on there. So thank you, Alistair. Now, I did indulge a little bit too much with that demo, but hopefully you found it interesting, and Marta will let me off. If you want to look like me and have this swag, you can get it on the store if you didn't tweet. If you made an amazing tweet, I'll go and look at these later, hopefully be able to send you one for free. There's lots of tutorials, docs.inlets.dev, they've got Slack as well. Recap, you can connect services and clusters with Inlets. There's a free open source version, does a lot of stuff for you, but you might need to do a bit more work. There's a pro version with commercial support and help if you need it that does TCP as well. And then these are the automation tools that I mentioned earlier that you might want to use. So thanks for listening, and I'd be really keen to hear any questions you've got or feedback. Contact me, alex@openfaas.com.